Hello, this is Mr. Boothman, and we are here in section 5.7, and this is graphs of the reciprocal trig functions. So in this section, we're going to finally talk about being able to graph cosecant and secant. It's a lot simpler than you are probably thinking, I promise. And then we'll finally get to talk about graphing the tangent and cotangent functions. Those are super fun. I think these are really cool graphs, so let's go ahead and jump right in. So, the reciprocal functions, let's remember that we have our standard forms of just the regular sine and cosine functions. We're going to graph the key points the exact same way that we have already learned, that we've been tested on, that we've practiced a bunch. And we are going to use sine, there should be a colon in there, sine for the cosecant, and cosine to graph the secant function. That should make sense. Those are the reciprocals of each. And for reasons that we're about to see, the intercepts become asymptotes, or places where the graph doesn't exist. And then our max and min points for sine and cosine turn into relative minimums and relative maximums. They switch. So let's take a look at exactly what I mean by all of that. I'm going to go ahead and give you the points for the sine function, okay? So we're going to just graph regular old sine of x, 3 pi over 2, 2 pi, 0, 1, 0, negative 1, 0. And if we plot those points, let's call this pi over 2, pi, 3 pi over 2, 2 pi. We'll call this 1, negative 1. So the regular sine of x graph will start here, 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 and here. Okay, we should be getting incredibly comfortable with the graph of the sine of x. And now let's ask ourselves, what is happening for the cosecant? So cosecant of x, we know, is the reciprocal of sine. That's equal to 1 over the sine of x. So let's plug in these numbers. So at x equals 0, cosecant is 1 over, I'm going to go ahead, I'm plugging in 0 here, 1 over the sine, which is 0. Well, that's undefined. I can't have 1 divided by 0. So that becomes an asymptote. So up here I said intercepts, the x-intercepts turn into asymptotes. And this is why. Because where the graph is crossing the x-axis, where y equals 0, I'm going to end up with 1 divided by 0. And that's undefined. So I end up with an asymptote at 0, an asymptote at pi, and an asymptote at 2 pi. Okay, now that was a little tricky. If you need to pause, take a second, rewatch that section, jot down some questions. Going ahead. And then, still continuing with cosecant of x equals 1 over the sine of x. If I want to plug in pi over 2, I'm going to have 1 over 1. So I still have that point. If I plug in 3 pi over 2, that was cosecant of pi over 2. Cosecant of 3 pi over 2 is 1 over negative 1. Again, I got it from there. So I'm down here. And then you can plug this into a calculator, or you can go ahead and plug in things like pi over 4, etc. But you'll see that the graph ends up looking like this. My max and min points, in this case my maximum point turned into a minimum. And here my minimum point turned into a maximum. And then those x-intercepts are asymptotes. That's basically it. Now if we want to look at the period, it still takes me 2 pi to repeat one entire graph of the cosecant. My domain is all real numbers except x cannot equal these values where it's an x-intercept. So each pi. So we'll call that k pi, where k is an integer. So if you remember when we first started talking in section 5.5 about the properties of the sine and cosine functions, I had us list the x-intercepts and the y-intercepts. Well, this is why the x-intercepts, in this case, become asymptotes. So this is where I have to restrict my domain. So those are where I have vertical asymptotes. And then my range, here I'm going from negative infinity up to -1, inclusive. And then there's no cosecant graph between -1 and 1, but then at 1 I'm starting and I go up to positive infinity. So here's my range for the cosecant graph. Okay, let's take a look at cosine and secant. So cosine graph, let's use black again. (1, 0, -1, 0, 1). Call this pi over 2, pi, 3 pi over 2, 2 pi, 1, -1, so here, 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 and here. And in this case, now, these zeros become my asymptotes. So that's at pi over 2, 3 pi over 2. It'll happen again at negative pi over 2, and so on. And then at 0, this becomes my relative min, relative max, relative min. Just like we got the cosecant. Going ahead and pause. If you need to jot down some more questions, that's fine. I know this is kind of a weird looking graph. I think these are super cool. But we're getting all of this from the fact that the secant of x equals 1 over the cosine. So if I'm plugging in, if I want to know the secant of 0, that's 1 over the cosine of 0, which is 1, right here. If I want to know the secant of pi over 2, that's 1 over the cosine of pi over 2, or 1 over 0, which is undefined. That's why there's an asymptote there. So we can again ask some basic questions about the secant graph. The period is again 2 pi. It takes me 2 pi to complete one repetition of the secant graph. The domain in this case is everything except pi over 2 plus k pi. Now those were where we had the x-intercepts for the cosine graph, where k is an integer. And that will be where we have our vertical asymptotes. And then the range is again from negative infinity to +1. -1, goodness, I can't talk today. That's my apologies. And then from 1 to positive infinity. So again, your maximum values became minimums, and your minimum values became maximums. And then anywhere we had an x-intercept, anywhere y equals 0 before, became a vertical asymptote. So how do we graph secant, cosecant? The exact same way we've been graphing. So let's take a look at our first two examples here. So I'm still going to start with, in this case, I want to graph cosecant. I'm going to start with the sine table, the reciprocal. So 0, 1, 0, -1, 0. And then plus pi over 4, I'm going to subtract pi over 4 from all my x values. Uh, 5 pi over 4, 7 pi over 4, and then multiply by 2, my y values. 0, 2, 0, -2, 0. And then I'm going to plot the sine. So negative pi over 4, we're going to call this pi over 2, pi over 2, pi, 3 pi over 2, 2 pi. So 1, negative 1. So here, 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 and here. So here's my sine function. And then anywhere I have an x-intercept becomes my vertical asymptotes. And then my relative minimums come from my maximums from the sine graph. And then my minimums from the sine graph become my maximums. So, same thing as before. I'm graphing the same sine function that I had, the same way that we've learned, except now I take all of my x-intercepts, they become asymptotes. I take all of my minimums, they become maximums, and my maximums become minimums. So if you want to try numbers 5 and 6 on your own, and I'll go through number 4 with you right now. So here I have the secant of 2x. So that means I'm going to take the table for cosine, because cosine is the reciprocal of secant. 2x right here, b is 2, so what does that tell me? The period is 2 pi over b, the absolute value of b, which is pi. So my new x values, I'm going from 0 to pi, and that means I'm counting by pi over 4s. My y values stay the same, so let's graph that. So this was pi over 2, pi, 3 pi over 2, 2 pi, 1, negative 1. So 0, 1. This is a horizontal compression here. My zeros become asymptotes. And then maximums become minimums, minimums become maximums. And that's how I get the secant and cosecant graphs, by transforming sine and cosine, just like we've been doing. All right. So again, try numbers 5 and 6 on your own. But right now we're going to finish up. We're going to talk about the graphs of the tangent and cotangent functions. These functions are a little different. They are a little different. So remember, if you will, that the tangent of an angle is y over x. So if I'm looking at my unit circle at the terminal points from my unit circle, y over x means that I am equal to 0 at 0. At pi over 2, here, I have 1 over 0. That's undefined. I'm back to 0 at pi. 3 pi over 2 is undefined again. And then 2 pi. I'm at 0 again. Same works for the negative. So negative pi over 2, if I go this way, that's undefined. Negative pi is 0. Negative 3 pi over 2 is undefined. And then negative 2 pi is a 0. And then if I want to get points in between, so let's think about pi over 4. My point here is square root of 2 over 2, square root of 2 over 2. Well, y over x there is just 1. So at pi over 4, I'm at 1. At negative pi over 4, that's going to be negative 1. And if we keep plotting more points, we'll see that we end up with a shape like this. And that happens in each of these sections of the graph. Now I know I just went through that a little quickly. That's because we don't spend our time graphing tangent and cotangent all that much. It's important to be able to recognize their shapes, but again, we don't end up doing this by hand very often. So if you see, the period is pi. From negative pi over 2 to pi over 2 is one full repetition. So my period for tangent and cotangent is pi. My domain is all real numbers except where I have pi over 2 plus k pi. K is an integer. Those are where all my asymptotes are. The range is all real numbers. I'm getting outputs for all possible y values here. And then my vertical asymptotes are where the domain doesn't exist. And endpoints here, I just mean that if I were to make a nice table for this, I'm going to be looking at this one period here. So negative pi over 2, negative pi over 4, 0, positive pi over 4, positive pi over 2. So I'm going from negative pi over 2 to positive pi over 2. And then at those endpoints, I'm undefined. At negative pi over 4, that was negative 1. At positive pi over 4, that was positive 1. And then at 0, I'm 0. So that is my table for the tangent function. Cotangent is very similar. Very similar. How can I best explain this? If we take this table that we just made for tangent and change it for cotangent, remember cotangent is 1 over the tangent function. So I actually think it's best to start at 0 here. And when I have 1 over 0, so if I'm looking at this column right here, 1 over 0 from tangent is undefined. 1 over pi over 4 right here, or 1 over the tangent of pi over 4, it's going to be 1. Pi over 2, tangent of pi over 2 was undefined, but now I have 1 over 0, which ends up being 0. A lot of fraction flipping going on there. And then 3 pi over 4 will give me negative 1. And then pi is undefined. So I'm just taking those from the unit circle. Again, I'm kind of going through this quickly, a little vaguely, just because tangent, cotangent, it's not stuff we worry about too often. So now if I graph this, so at 0, I am undefined, so I have a horizontal or a vertical asymptote there. At pi over 2, I'm 0. Pi over 4 is, pi over 4 is positive 1, negative 1, and then at pi I have an asymptote. So that pattern is going to keep repeating. So I took my tangent function and I got the reciprocal. So this is what cotangent ends up looking like. The period is still pi. The domain is all real numbers except x equals k pi. K is an integer. That's where I have those vertical asymptotes. The range is all real numbers. And then my endpoints, in this case, I'm going from 0 to pi in my table. We're almost done. Sorry, this video is going a little longer than I'd hoped. You are going to try numbers 10 and 11 on your own. I'm going to go through number 9 and 12 with you. So let's start with number 9. I'm going to take my table for the tangent function, that table that we just made together. Oh, goodness. Pi over 4 is smaller than pi over 2. 2, 4, and then like that. And then, again, coming from this table up here, the tangent function is undefined here and here. It equals 0 at 0, -1 at -pi over 4, and then +1 at +pi over 4. And then in here, b equals 1/2. So my new period is 2 pi over the absolute value of 1/2, which is 4 pi. Except, I hope you caught my mistake just there. Remember that, and this is the tricky part for tangent and cotangent, the period equals the new period will equal the normal period divided by the absolute value of b. Well, the normal period for the tangent and cotangent functions is just pi. So that means my new period is going to be pi over the absolute value of 1/2, which is 2 pi. So instead of going from -pi over 2 to +pi over 2, I'm going to go from -pi to +pi. Still at 0, then I'll count by pi over 2's. So -pi over 2, -pi, pi over 2, +pi, +1, -1. So here, 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 and then vertical asymptotes. Horizontal stretch. It was kind of a lot, and that again had to do with changing the period, and changing period for tangent and cotangent is a little different. My formula becomes pi over the absolute value of b. All right, last problem, number 12. I apologize, I feel like I've been a little distracted during this video. I'm making this here at school, and it's awfully distracting. So let's finish number 12. Cotangent, so I'm going to start with that table I made for cotangent up here. I'm talking about this table right here. X, Y. I'm going to start at 0 and then count by pi over 4's. And then this was undefined. 1, 0, -1, and then undefined. And now I have a phase shift pi over 2 to the left. Subtract pi over 2 from all of these x values. -pi over 2, -pi over 4, 0, pi over 4, pi over 2. And then I have a vertical stretch. I'm changing the amplitude to 2. So take my y values, multiply them by 2. Multiplying something undefined by 2 is still undefined. And then I can graph this. So going from -pi over 2 to +pi over 2. One, 2, -1, -2. Phase shift, and I've stretched this vertically. All right, so I hope I didn't confuse you. These tangent, cotangent, secant, cosecant graphs I think are really cool. We don't use them nearly as much as sine and cosine, but they are still important for you to be able to recognize. And then I wanted you to see that we can graph their transformations just as simply as we did sine and cosine. Just a couple little things change. So jot down questions, do these practice problems. Go ahead and bring any questions to class, and I'd be more than happy to help you with them. All right, thank you so much, and have a good day.